All right, so welcome to my series of videos on statistics. And in this particular video, it is what I call the foundational video to statistics. So we are going to talk about where, the how, the why of data collection. So by the end of this lesson, you should know the various data collection methods. You should know the difference between a population and a sample. You should understand the similarities between the different sampling methods and understand how to categorize data by type and level of measurement. Now, what is business statistics? So business statistics is simply a range of procedures that we use to collect data, analyze the data to a more meaningful information so that we can use it for business decision making. All right. So it's just a range of procedures for collecting data, analyzing data into a more meaningful information so that we can use it for business decisions. That is business statistics. So in simple terms, it's just the application of statistics to business decisions. Now, everything about statistics hinges on two main branches. So the two main branches of statistics is that we are either describing a phenomenon or we are making inference about a phenomenon. Now, here, descriptive statistics is just the statistical procedure designed to describe data. All right. So descriptive statistics is simply the statistical procedures designed to describe data. So for instance, in a class, if you collect data on the age of students and you collect data on their academic performance in terms of their CGPA, if I'm just describing their age and their CGPA, I can just say that on the average, this is their age. And on the average, this is their CGPA, all right? So descriptive statistics simply talks about presenting statistics on the obvious aspect of the data. So something like their data on their age and the data on their CGPA. Obviously, I can find the average age. Obviously, I can find the average GPA. All right. That is why some books say that descriptive statistics is actually summary statistics or summary measures. So in my series of videos, I'll teach on descriptive statistics in detail. Now, when it comes to inferential statistics, okay, inferential statistics, it rather goes beyond the obvious aspect of data. For instance, if I want to see how age affects GPA, or if I want to see the correlation between age and CGPA, I am going beyond what is obvious from the data to make inferences, okay? So anytime we go beyond the obvious aspect of the data, like the average and those things, to make inference about the data or to make inference about some unknown aspect of the data, we are talking about inferential statistics. So inferential statistics helps us to draw inferences or helps us to go beyond the obvious aspect of data to see whether there are some relationships or etc. So the descriptive statistics can be done using charts and graphs, or it can be done using numerical measures, right? So in my series of videos, I'll teach on using chart and graph as a descriptive procedure, and I'll also teach on using numerical measures as a descriptive procedure. Then the inferential procedure talks about making estimations about a population. So there we will talk about point estimate and then confidence interval, right? And then it also talks about hypothesis testing, okay? Using evidence to rather accept or refute a claim, a research claim. We can use evidence to accept or refute a claim, all right? That is hypothesis testing. So in my series of videos, I also teach on hypothesis testing. So that is what inferential procedures are about, estimations as well as hypothesis testing. Now, let's come to issues of data collection. There are several ways we can collect data, right? We can collect data through experiments, through telephone survey, through questionnaires and written survey, and through direct observation and personal interviews. So if I want to collect data for research, these are some of the procedures I can use to collect the data for research. Now, when we talk about experiment is normally done by the sciences, okay? It is a process which produces a single outcome, whose results cannot be predicted with certainty. So in sciences, they may want to test something like osmosis. Once they are doing osmosis, okay, it will produce a single outcome, whether the water will diffuse out of the membrane or it will come into the membrane. That's osmosis or diffusion. So that experiment will produce a single outcome, or that process will produce a single outcome, but we cannot predict it with certainty. We don't know what will happen. So then, in doing experiments, you always have to plan. And a plan for performing an experiment is called experimental design. A plan for performing an experiment in which a variable of interest is defined is called an experimental design. An experimental design. Now, another way of collecting data is through survey, telephone surveys, all right? When we talk about survey is simple. Survey is just collecting data from respondents, all right? Collecting data from human beings or respondents. Okay, so when you are doing research, you may want to collect data from human beings, which are your respondents, okay? Now, you can do that through questionnaire. I can collect data from respondents through questionnaire, or I can do it through telephone, all right? Now, whether I'm collecting data from human beings or respondents through questionnaire or telephone, I may employ what we call close-ended questions. So close-ended questions, when I give or when I pose the question to the respondent that I'm collecting the data from, okay, what it means is that I will give the person a predefined set of choices. So I can ask, where are you likely to be on weekends? A, church. B, at a club. C, on the football field. D, at home. Now, anything the person chooses, it will give me information or data. But then in the question, I have restricted the person to these choices for him to make. Okay, so when that happens, we call it close-ended questions. All right, close-ended questions. Then we can have open-ended questions where I can ask the person, where are you likely to be on the weekend? Then the person will give his own answer. And when that happens, we call it open-ended questions. Open-ended questions. Then we can also have demographic questions. Demographic questions are questions relating to the respondent's background and characteristics and attributes. When you ask questions on somebody's age, his income, his level of education, his marital status, his gender, all these things are referred to as demographic questions. So survey is simply collecting questions, collecting data from respondents. And when it is done on the telephone, we call it telephone survey, all right? And when it's done through questionnaire, we call it questionnaire survey, okay? So these are the procedures for conducting a telephone survey, which you can simply read, okay? Define the issue, define the population of interest, develop the survey questions. You have to. And now one thing you must know that whenever you are going to collect data, we don't just send our questions there like that. You have to pre-test it. You have to ask a small group of people the questions and see whether the questions make sense before you can apply it on the larger sample that you are going to collect the information from. Okay, now, another way of collecting data is written questionnaires, okay? As I said, it's similar to telephone survey, but here we send the people questionnaires to collect the data. We don't call them on the phone and read out the questions and solicit for answers. We send out the questionnaires to them. So here too, as I said, it can be close-ended questions or open-ended questions, okay? Another way of collecting data is also through observation. So for the police system in Ghana now, you see, when they want to collect data, they can just plant a CCTV camera somewhere, or even any security service. They want to collect data on what happened or the events that happen at a certain place, they can plant a CCTV camera there. And once they do that, they are able to collect that data through observation, all right? So data being collected through observation is physically observed, and then we record whatever takes place. Now, the disadvantage of this method of collecting data is that it is very subjective, because it is how the person perceives what he saw, or what I'm trying to say is that how the person perceives what he saw would determine what he writes or what he records, okay? And also, it is also time consuming. Then, another way of collecting data is through interviews, all right? So you can also go to somebody and conduct a personal interview. You ask the person a question, and then the person will give a response. So we have structured interviews, and then we have unstructured interviews. Structured interviews are where, or it's a situation where when you are going to conduct the interview, you have a predefined list of questions you are going to ask. So we are going to conduct an interview, but we have a predefined list of questions. When that happens, we call the interview a structured interview. Okay, a structured interview. Structured interview. All right. And then when you don't have a predefined list of questions you are going to ask, but then you have a general idea of the area where you are going to ask the questions, in which case sometimes even your question can even, the response to your question can even trigger further questions, you are doing an unstructured interview. So for structured interviews, the questions are scripted, and we just ask the person the questions direct. But for unstructured, you don't have any predefined list of questions. You ask the questions more broadly, and the person's answers will trigger further questions. So these are the various advantages and disadvantages of the data collection method. For experiments, it provides control. We have pre-planned objectives, but then the disadvantage is actually time consuming. It requires so much planning. For telephone surveys, it is timely and relatively inexpensive because you just call the person on the phone to collect data. But on the other hand, it has poor reputation. All right. Then it has limited scope and length. Then also we have questionnaires, its advantages and disadvantages. Then also we have direct observation, its advantages and disadvantages. For questionnaires, when you mail questionnaires for people to answer, it is relatively inexpensive, and you can expand the length. And you can use both open-ended questions and closed-ended questions. But the disadvantage is that because questionnaires is not real time, you just give it to the person for the person to fill or whatever. What it means is that you can have a low response rate. People will not fill everything because you are not on them. It's not like an interview where it is live. You give them the questionnaire and ask them to fill. They may leave empty spaces or they may not even respond. All right. Then it requires exceptional clarity because you are not there to explain the questionnaire to the person. So it requires so much work to make your questionnaire have a certain level of clarity. Direct observation, the advantage is that it expands analysis opportunities and there is no respondent bias because you are directly observing the respondent. There is no respondent bias. However, there can be an observer bias. The person who is observing, there might be a bias in how he will interpret the data. And then sometimes it is also costly, all right? So these are some of the data collection issues that you may encounter. Data accuracy, interviewer bias, non-responsive bias, that's when people don't respond to your questionnaires. Interviewer bias is that if I'm the one conducting the interview on somebody, how I would record the data or how I interpret the interview may be biased based on me, right? So let's say person A and B can conduct interview with the same set of questions, but how person A conducts the interview, the responses he will get, or how he will interpret the responses that he will get will be different from that of interviewer B. All right. Then we also have selection bias. observer bias, which normally occurs in observation. So if I'm the one doing the observation, how I will perceive what I'm seeing may be different from another person. Then we also have issues of measurement error, internal validity, and then external validity. All right. When we talk about internal validity, we are looking at the fact that the instrument that you are using to collect the data, or even how you are measuring your variables internally, are they valid, right? For instance, if you have a questionnaire and you say that on a scale of, let's say, 1 to 7, okay, indicate the level with which you agree to the following statement. Statement 1, I always go to class early. Statement 2, I do all my assignments. Okay. Statement 3, I don't like revision of what I've been taught. Now you realize that statement 1 and 2, they connote that the student is serious. But statement 3 connotes the student is unserious. Now, if you are measuring seriousness of a student, we can't use these 3 questions to measure, because 2 of them are going in a certain direction and 1 of them is going in the opposite direction. So when that happens, we can say that the way you are measuring the variable, it lacks internal validity. Within it, it's not valid, the way you are measuring the variable. Then we can also have external validity, where we want to check if how you are measuring the variable externally, it is accurate, all right? So that is that. Now, in the introduction to statistics, we also need to understand issues of population, samples, and then census. Now, when we talk about a population, population is a set of all objects or individuals of interest or measurement obtained from all objects or individuals of interest. So for instance, if I'm collecting or if I'm doing a research on, let's say, a school of business students, all right, the population becomes all school of business students, all of them. Now, if I cannot reach all of them, I can use a subset of the school of business students to represent all of them. So a sample, in essence, is a subset of the population, all right? Then we also need to understand what a census is. Census is simply taking measurements from the whole population. So if I'm taking, let's say, the GPA of all school of business students, I'm doing a census study because I'm enumerating the entire set of measurements taken from the whole population. That is why in Ghana, when they are counting or when they are taking certain measurements like age, sex, and all those things from all the population of people in Ghana, we are saying that we are doing a population census. All right. So basically, if this is our population, a sample is a subset of the population. All right. So a sample can be a subset of the population. So we can choose any subset of the population as a sample. Okay. Now, this means that, you see, whenever we compute a measure for a population, and we compute the corresponding measure of a sample, it should have different names. So for instance, any measure that we compute for a population is called a parameter. So if I compute the mean of a population, the mean now becomes a parameter. If I compute the standard deviation of a population, it is a parameter, all right? But if I compute the mean for a sample, the mean is called a statistic. So any measure, be it mean, standard deviation, differences, correlation, whatever it is, if I compute that measure for a sample, the generic name for that measure is called a statistic. Okay, so all measures computed for a sample, they are called statistics. And all measures computed for a population is called a parameter. Okay. Now, why do we sample? Why do we sample? Why is it that we don't use the entire population? Ideally, using the entire population would have been very good for your research you are doing. But why do we sample? Now, these are the reasons why we sample. We sample because, number one, because of cost. When you are doing the research and you want to use the whole population, you might incur so much cost. So we sample, number one, because of cost. Number two, we can sample because of time. So cost consideration. We also have time consideration. Number three, we can sample because of impracticability. Of using the entire population. So sometimes it is just not practicable. For instance, if I'm doing a research on school of business students and I have to collect data from them using questionnaire, it is very unlikely that I'll be able to reach all the school of business students. It's very unlikely. When I go to classrooms, maybe some people didn't come for class on that day. Some people have even left campus because maybe they have to attend to something at home, etc. So sometimes it is just not practicable to use the entire population. So these are some of the reasons why we sample. These are some of the reasons why we sample. Now, if we are sampling, then what are the methods of sampling? What are the methods that we can use to sample? Now, some of the methods are statistical or what we call probability. So some of the methods in sampling, when we use it, it means that each and every member of the population has an equal chance of being selected, all right? So when we are using a statistical sampling technique or a probability sampling technique, it means that we give each of the elements in the population equal chance of being selected. However, if we are using a non-statistical or what we call a non-probability sampling technique, what it means is that we do not give them equal chances of being selected. We do not afford the elements in the population equal chance of being selected. Some of the non-statistical or the non-probability sampling techniques is convenience. For instance, let's say if I teach a certain class, okay, in a school of business, and I want to take data from school of business students, it will be convenient for me to take it from the people I teach. That means I didn't give other people the chances of being selected. So then convenience is a non-statistical sampling technique. Some of them too, another one is judgmental. Sometimes you are going to collect data from certain people, but by the mere fact of their appearance, you don't collect data from them. You collect data from people that the appearance looks good and you think you can get good data from them. So when that happens, that is a judgmental sampling. And then we also have others like snowballing, etc. Okay, there are a couple of them. Now, let's get into the sampling techniques proper. So these are some of the non-sampling techniques. Convenience, collected to non-statistical or the non-probability. Some of them are convenience, collected in the most convenient way for the researcher, and judgmental, when we form opinions about people who is most likely to provide us good information. So with this, it doesn't give the elements in the population equal chance of being selected. Okay. But more importantly, I want us to go to the statistical sampling techniques. Statistical sampling techniques. Now, before we go there, we need to know that the statistical sampling techniques is called probability sampling techniques, and it's also called random sampling technique. It has three names: statistical sampling technique, probability sampling technique, or random sampling technique. So there are four of them. We have the simple random sampling, we have the stratified random sampling, we have the systematic random sampling, and then we have the cluster random sampling. Now, let's start with a simple random sampling. So simple random sampling, each possible sample of a given size has an equal chance of being selected. So nowadays, when we want to do simple random sampling, what you could do is that you can get the information, of the entire population, or you can get, the number of people in the entire population and label them so that you can identify them later. And you can feed it into computer, then you can just give an Excel command that Excel should randomly select maybe 100 out of 500 people for you. So the Excel will do it randomly without even having any prejudgment about it. The computer will randomly choose 100 people for you. So when that is done, we call it simple random. But you see, whenever you are doing a research and you have special groups of interest in your research, you cannot do simple random. For instance, if I want to see how gender affects academic performance, I cannot do simple random. Okay, I cannot do simple random. The reason is that if I do simple random sampling, the computer may randomly choose a sample which consists of only male. And when that happens, I cannot also see how being a female also affects your performance. That means that it will be difficult for me to know the effect of gender, whether being a male or a female, how it affects your performance. So anytime in your research, you have special groups of interest like a gender, maybe college that you belong to. So let's say if you want to look at effect of somebody's college that he belongs to, how it will affect the person's GPA. If I do simple random, what can happen is that the computer can end up choosing all the random samples from just one college. So it will be difficult to know how other colleges, their students, how being in that college affect their academic performance, their GPA. So anytime we have special groups of interest, we do what we call stratified random sampling. Okay, so stratified random sampling is that, first of all, you group the entire population into the groups of interest. So if I want to know how a college, being in a college, how it affects the students' academic performance, I'll group the entire population into the colleges. So I'll group this. I'll have college 1 as a subgroup. I'll have college 2 as a subgroup. I'll have college 3 as a subgroup, and I'll have college 4 as a subgroup, whether it is College of Humanities or whether it is College of Arts. I'm just labeling them colleges. So then, after grouping them into the subgroups, each subgroup is called stratum, right? Stratum. And the plural for the subgroups is called strata. Plural of stratum is strata. So I'll first of all group the population into the subgroups, and then I'll use simple random to choose from each subgroup, all right? So that eventually, when I combine all the simple randoms from each subgroup, I'm going to get a final sample to be this, okay? So we use stratified random sampling when we have special groups of interest. So we have to, first of all, group the entire population into the special groups of interest, and we use the simple random to choose from each subgroup. The next one is systematic. Systematic is just like the simple random, but just that we now do it in a systematic way. How do we do it? We do it by choosing the kth person, and then K is equal to population divided by sample size. So for instance, if I want to choose 8 people, which is the sample size, from 64 people, I'll just divide the population of 64 by the sample size of 8. So I'll get 8. So it means that I'll arrange the people from number 1 to number 64, and I'll choose every 8th person. So I'll count 1, 2, 3, 4, 5, 6, 7, 8. So the 8th person will stand aside. Then I'll continue counting 1, 2, 3, 4, 5, 6, 7, 8. So the 8th person will stand aside. So by the time I finish counting up to the 64, you realize that I'll choose the person number 8, number 16, number 24, number 32, number 40, on and on and on and on. So you realize that when I do that, I'll get 8 people by choosing the 8th person. Another example, if I want to choose 5 people from 20, it will be 20 divided by 5, which is 4th person. So I'll arrange the people from number 1 to number 20, and I'll count 1, 2, 3, 4. The 4th person stands aside. Then 1, 2, 3, 4. The next 4th person stands aside. So what will happen is that I'll end up getting 5 people from a population of 20 by choosing every 4th person. So that is how we do the systematic random sampling. And finally, the cluster random sampling is done when we are interested in geographical areas. Okay, geographical areas. So every cluster will have different people. So every cluster will have A, B, C, D. Another cluster will have A, B, C, D. Another cluster will have A, B, C, D. Okay, another cluster will have A, B, C, D. So those of us who know what we call cluster of schools, in the cluster of schools, there can be a Methodist school in there, there can be a Presby school in there, there can be a Pentecost school in there, there can be an Islamic school there. So normally cluster is done when we are interested in doing research according to geographical areas. So you can realize that within one cluster, the elements there are different. Okay, A, B, there are different elements. But if you compare a whole cluster to another whole cluster, they are the same. That is why we say that for cluster, internally the elements there are different. But if you compare one cluster against another cluster, generally they are the same. The cluster as a whole, as compared to another cluster as a whole, they are the same. So the difference then between cluster and stratified is that stratified will have A, and will have B, B, B. And another sample will have C, C. Stratum will have C, C, C. Another stratum will have D, D, D. This is stratified. Internally, within one stratum, the elements are the same. But if you compare one stratum against another stratum, it's different. But for cluster, as I've shown you, in every cluster, the elements are different. But if you compare one cluster against another cluster, the elements are this. I mean, the cluster as a whole is the same as another cluster. Now, we'll end this session with data types and data measurement levels. Now, when we want to look at types of data in terms of their timing, the data can either be a time series data or it can be a cross-sectional data. And then when we're looking at data in terms of their type, it can be a qualitative data and a quantitative data. Then we can further break the types into levels such as nominal, ordinal, and then interval and ratio. Okay. Now, when we talk about time series data is a consecutive data values observed at successive points in time. So for instance, let's say if you collect data on somebody's income for the past 10 years, it is time series. The reason is that it is one unit, but with just one person, but then at several years, okay? On the other hand, if you collect data for so many people, data on their salary for so many people, but just in 1 year alone. So here we have several units, but 1 year. That becomes cross-sectional. So cross-sectional is a set of values observed at a fixed point, but for several units. All right. Set of values observed at a fixed point, but for several units. That is cross-sectional data. Now, again, we can group data into qualitative or quantitative. We can group data into qualitative or quantitative. Now, when we say quantitative data is data which is inherently numbers. Intrinsically, they are numbers. For instance, somebody's age is a number, naturally is a number. Somebody's income, naturally is a number, all right? So, such data are usually continuous. Okay, it is continuous. Numbers are continuous from 1 up to infinity. All right. On the other hand, if the data is naturally not numbers, but the data is inherently qualities or categories, we call it qualitative. So data like marital status, being single, married, etc., etc., they are not numbers, they are just qualities. Even somebody's eye color, blue, brown, yellow, red, black, whatever, they are just qualities, okay? And because they are qualities, they are not on a continuous, it can be up to infinity. We can just, because they are qualities, we can just categorize them. So quantitative data is normally continuous, qualitative data is normally categorical, right? Now, what I want you to know is that, you see, for categorical data, sorry, okay, they are usually qualities. Okay, but what I want you to know is that there are some qualities that we cannot rank with any logic. For instance, qualities like color preference, yellow, blue, black, white, or whatever. We can't rank it in any way. We can just name it. We can just name it. That, okay, this is black, this is blue, this is red, this is yellow. We can't rank it in any way. Now, another data like somebody's region of birth, all right, where the person comes from. We can just name it that is from the region A, B, C. Only no other factors constant, we cannot rank it. So any categorical data that we cannot rank, we call it nominal data. So nominal data is any categorical data or categorical or qualitative data that we cannot rank. So for instance, somebody's gender. So data on gender, male or female, we cannot rank. Okay. Somebody's color preference, we cannot rank. Somebody's college, whether you are from College of Human, as in college type, in terms of whether you are from College of Humanities and Legal Studies or College of Agric and Natural Science or etc. You can just categorize you in that college, but holding other factors constant, we don't rank it. Okay. So any categorical or qualitative data that we don't rank, it is called nominal. However, there can be categorical data that we can rank. Example, marital status. So marital status, single, married, divorced, etc. Although they are just qualities or they are just categories, we can rank it according to a certain logic. So ordinal data, therefore, is categorical data, categorical or qualitative data that can be ranked. Example, marital status. Another example is position in end of semester. Now remember that position in the end of semester is not numbers. It's not numbers. First, when somebody is first, okay, it's a quality, it's not numbers. Just that we can use numbers like 1st to represent first, but this word first here is not a number. Okay, it's not a number. It's like people wearing jerseys. Okay, jersey for a football game. The jersey number is just a label on the person. It doesn't mean that if I wear jersey number 11, it doesn't mean that I play more than somebody who wears jersey number 2. Or if somebody wears jersey number 30, it doesn't mean that the person plays more than somebody who wears jersey number 8. All right. But if somebody wears jersey number 11, it doesn't mean that the person plays lesser than somebody who wears jersey number 44. So you must learn to distinguish between when numbers is used as a label for categorical data and when numbers is a number itself in terms of quantitative data, right? So position in the end of semester is actually an ordinal data. It is a qualitative data that we can rank according to a certain logic. Now, on the other hand, we have quantitative data. Here we've said they are intrinsically numbers, but that one too, we can break it into interval data and then ratio data. Now, interval data is quantitative data. Quantitative data that does not have a natural zero. Zero means something. A clear example of this is temperature. You see, when somebody's temperature is 0 degrees Celsius, it doesn't mean he doesn't have temperature. Okay, what it means is that his temperature is very low. So a clear example of interval data is temperature. Another example is that sometimes when you see a questionnaire, they will say on a scale of, let's say, 0 to 5, indicate your level of agreement. If somebody chooses 0, it doesn't mean that he doesn't have anything called agreement. What it means is that his agreement is very low, all right? So what we are saying here is that interval data is a quantitative data that does not have a natural zero. That means that whenever you see 0 in interval data, the 0 means something. It doesn't mean there's nothing there. On the other hand, ratio data is quantitative data that has a natural zero. Okay, which means that 0 here means nothing. Example is income. Okay, when your income is 0, it's 0. It doesn't mean your income is low. It means you don't have, right? It means you don't have. So that is the difference between interval and ratio data. But of course, because the two of them are usually numbers, most books, they write interval or ratio, but the clear difference between the two of them is that interval does not have a natural zero. Ratio data has a natural zero. Okay. Ratio data has a natural zero. Okay. Now, we all know that whenever you collect qualitative data, we can't do so much numerical analysis with it. So that is why in terms of doing analysis, the most preferred is quantitative data, which is ratio or interval. Because when you collect qualitative data, like color preference and etc., you can't even find mean. All you can do is find mode, the number of people who chose color A, the mode. And we can't find mean, and we can't do so much analysis with qualitative data. Okay. So as the data moves up, the level of analysis also goes up. So when it is quantitative, like ratio or interval, we can do more analysis with it than when it is ordinal, and also than when it is what? Nominal. Because for ordinal like this, it is qualitative, but because we can rank it, we can find median. Okay. And we can also find mode for ordinal. Because it is qualitative, but because we can rank it, we can find median. And again, we can find mode like how we do for nominal. All right. And it ends there. We can't find mean. But when it gets to ratio or interval, that is usually numbers. Because it's numbers, actually numbers, we can find the mode, we can find the mean, and even we can find the median, and even find the mean as well. But that is why we say that for ratio or interval data, we can do so many analysis with it. So these are the steps we go through when we are categorizing data. All right, identify each factor in the data set, determine whether the data are time series or cross-sectional, determine which factors are quantitative and which are qualitative, determine the level of data measurement for each factor. So this can be done in Excel as well. So this will bring us to the end of the introductory video on statistics. In the next video, I'll be teaching on graphical measures of descriptive statistics. All right. So kindly like, comment, share, and most importantly, subscribe. Thank you.